Hello guys, welcome back to our tutorials. Today we'll be continuing with the trigonometry. But before we go more into the trigonometry, I would like us to talk about some few things like in geometry. So let's start with I want to talk about what angles. In order to better understand the trick, you need to know what angles are. So what is an angle? An angle is a figure that's formed when what two rays meet. So if you have one ray and another ray, so a ray must have an arrow. When they meet, the figure that's formed is what you call what an angle. So that's an angle. An angle is formed where two rays what meet. Okay, so we can have an angle here, an angle here, an angle here. Mostly they talk about this as what them meeting at what one particular endpoint. Okay, what is here is an angle. Okay, then the most important thing here is the type of angles that we'll be dealing with. We'll be dealing with a lot of them, but I will just talk about a few of them, and then you guys can go and read more on the rest. Okay, so the first common one is what the acute angles. So an acute angle is any angle whose measure is what less than 90. So the acute angle, its measure is what less than what 90 degrees. Okay, so that's an acute angle. And we have what a right angle. The right angle is any angle is an angle that has exactly what 90 degrees. So it has a measure of exactly 90 degrees. Then we have an obtuse angle, which has a measure. The measure of the angle is what is greater than 90 degrees, but what less than 180 degrees. So if the angle is in this range, it is what an obtuse angle. It is greater than it's greater than 90, but what less than 180 degrees. Okay, then we have a straight angle. A straight angle is an angle whose measure is what exactly 180 degrees. We have reflex angle. Which is 180 degrees less than the angle less than 360. We can draw these angles, but like you can do that one when you're free. Then we have full angle. Yeah, that's right. We have full angle too. That's exactly the angle is. The measure is exactly 360 degrees. So that's like full circle. So that's full angle. We also have some interesting angles that we'll be talking about. So we have complementary angles. Complementary angles. So two angles are complementary when their sum is equal to 90 degrees. So angle A and B are complementary when A plus B is equal to 90 degrees. Okay, then we have supplementary angles. Also similar to this, x and y are supplementary if x plus y is equal to 180 degrees. So please keep all these angles, like all these basic definitions in your head. We'll be using them in our throughout this trigonometry. So the next thing I would like to talk about is triangle. You know, trigonometry is for triangle measurement. So let's talk a bit more about triangles. Okay, so triangles. If they say triangles, what comes to your mind? First, you should know that triangle is what? A polynomial. A polygon, sorry. I say polynomial. It's a polygon, okay? A triangle is a polygon, which means that it has what? Three sides. Or it's a polygon of what? Three sides. So polygon of three sides. And it has what? Three internal angles. Okay, it has three internal angles. So if you draw a polygon, a typical polygon should have three sides. So sides A, B, C, then angle A, angle what? B, and angle C. So depending on the relationship between this angle, we can have various type of what? Triangles. So I'll be talking about the types of triangles over here too. Type of triangles. Okay, so we can have what? A scalene triangle. In a scalene triangle, it has all the sides and angles are what? Different. So all sides and what? Angles are different. So when you draw it, a typical scalene triangle will have this. Yeah, so all sides and angles are what? Different. So that's scalene triangle. Then we have what? An isosceles triangle. That one what? Two sides are what? So two sides are equal. Two sides are equal. And two sides are equal, and two angles opposite to the two equal sides. Or explain that are what? Equal. So this is what it means. So if you have what? An isosceles triangle, this side and this side are equal. This is A and this is A, and let's say this is B. The angle here is opposite to this side, and the angle here is opposite to this side. So these two angles are what? Equal. So that's what it means by the second part, which is two angles opposite to the two sides are what? Equal. So that's the meaning. So this angle here is not what? Equal to these ones. Okay, these two, only these two are equal. Then the next type of triangles that we'll talk about is the what? Equilateral triangle. Equilateral triangle. That one, all the sides are what? All sides and angles are equal. So when you draw that one, it can be this. Everything is what? Equal. Yeah, so with this kind of classification, or the types of based on classification, this is based on what? This is on the basics of length. Okay, this is on the basis of what? Length of the side. There is a second type of classification which is based on the angles, based on the measurement of angles. So types of what? Types of triangles based on angle measurement. We'll have what? So you can guess that we'll have acute angle what? Triangle. In that one, all the angles are what? All the angles are less than 90 degrees. Then we have right angle triangle, where we have what? One of the angles should be equal to what? 90 degrees. 90 degrees. So when you draw this one, I think this one, the angle here should be what? Less than what? 90 degrees, like all the angles. But when you draw the right angle triangle, it looks like this, with this one having what? 90 degrees. Yeah. Then we have obtuse angle triangle. So as you may guess, with respect to that one, all the what, or one of the angles is what? Greater than what? 90 degrees. So with respect to this one, it has what? Any of its angles greater than 90 degrees. Yeah, so that's an obtuse angle triangle. So there should be angle here. Okay, angle triangle. So these are the basic, like, just we can have more, but just focus on these three. Okay, so we've talked about what? Angles, and then now we have talked about some basis of triangle. We can talk about the area, perimeter, and co, but that's for what? That's not something that we'll focus on in trigonometry. So now let's go and talk about the next thing we'll be talking about is actually finding the sine, cosine, and tangent of what? Some common angles. So common angles like 30 degrees, 60 degrees, we can have 45 degrees, and co. Okay, so let's do that. Yeah, so let's consider first an equilateral triangle. So consider an equilateral triangle of size A. I'm trying to write everything for you guys. Equilateral triangle of size A. Okay, so if you have that equilateral triangle, forgive my drawing, so we have, let me just label this one A, B, and C, and the side here is A, here is A, and here is A. And since it's an equilateral triangle, all the angles will be what? 60 degrees, 60 degrees, and this one is 60 degrees, and when you divide into two, you get what? 30 degrees here and 30 degrees here. Okay, and this is what? The height of what? This triangle. This is the height of this triangle. Now if we take only one of the triangles that we get over here, let's take the one that contains A. Remember, if we divide this, the height will meet this side as towards 90 degrees. So the angle here will be what? 90 degrees. And then we'll have A here. And since we are dividing this will now be, this side will be what? A over 2. And this side will also be what? A over 2. So this will be what? A over 2. This is 60 degrees. This will be 30. This is A. And then let's label this side as what? B. And then this is what? C. Okay. And then we have the height to be H. So let's find the height. So from Pythagoras theorem, the hypotenuse squared is equal to what? The opposite squared plus the adjacent squared. This is a over 2. So we'll be having a squared to be equal to h squared plus a squared over 4. We are interested in a, so we'll send this one to the other side. If you do that, you're going to get h squared to be equal to a squared plus a squared over 4, and this should be equal to 4a squared. If you send that, you get negative, so this place should be negative minus a squared all over 4, and this should be equal to h squared. So h squared will be equal to what? 3a squared over 4. So when you take square root of both sides, you get h to be equal to what? Square root of 3 over 2a. So this is what you get. You get plus or minus. Now you're interested in the positive, so let's just take the positive for now. So then when you redraw this, you will get a over 2, you get a, and you get square root of 3a over 2 a b c. So let's not forget the angles 60 degrees and 30 degrees. Okay, so let's go and find the sine and cos of what these angles and see what you'll get. So don't forget this side. So I think let me just draw it here so that there will be no need to be going back and forth. So here is D. Okay, so now let's focus on what? The 30 degrees. Okay, on the 30 degrees. Sine of what? 30 degrees, considering this triangle, will be equal to what? So we know sine is equal to opposite over, so let me just write the so-called as well. So opposite over hypotenuse. So this is 30. Its opposite is this, right? And its hypotenuse is what? A. So the opposite is what? A over 2, and the hypotenuse is A. This will give us what? A over what? 2A, which is equal to what? 1 over 2. Then let's check cos of what? 30. This will be equal to what? This 30. Cos is adjacent over what? Hypotenuse. The adjacent is what? Root 3 over 2. So we have root 3a over 2 all over hypotenuse is a. You simplify that, you get root 3a all over 2a. The a also cancel, you get what? Square root of 3 over 2, right? Then let's check tan of what? 30 degrees. Tan is equal to opposite over what? Hypotenuse. Adjacent, sorry. So the opposite is a over 2. And then what the adjacent is square root of 3a over 2 over 2, right? Let's simplify that. So if you simplify that, you get, okay, let me just do this simple so that you guys will see 2 over square root of 3a. Then that will give us what? 1 over square root of 3. Okay, so tan 30 will be equal to 1 over square root of what? 3. Now let's focus on what? 60 degrees. Now the focus is on 60 degrees, where the opposite is this and the adjacent is this, and this is the hypotenuse. Sine of what? 60 degrees will be equal to what? The opposite is equal to this, and the hypotenuse is what? A. So here we'll get what? Square root of 3 over 2. Cos of 60 degrees will be equal to what? 1 over, so A over 2 all over A, and this should give us what? 1 over 2. And tan of 60 degrees will be equal to what? Tan of 60, this is opposite, so square root of 3A over 2 all over A over this. This should be equal to square root of what? 3. So this is what we have. So we have sine of 60 to be half, cos of 60 to be what? Square root of 3 over 2. Tan of what? 30. No, this is 30, sorry. And tan of 30 to be equal to square root of 1 over 3. Sine of 60 to be equal to square root of 3 over 2. Then cos of 60 half, tan of what? 60 should be equal to what? Root 3. So that's why the sine of and cos of these angles are this way. So you don't really need to like memorize these values in your head, but you should know how to like solve them for you. Like when you forget, you can easily solve these things. Okay, now we are going to find for 45 degrees. So let's go and do that. To find the angle like for the 45 degrees, we are going to consider what? A square. So consider, and also before we do that, I want to talk about something else. Okay, let's just talk about the square and then talk about it. So we are considering a square, forgive me of my diagram, so 90 degrees everywhere. Okay, now if we divide this square, we draw a diagonal. The angle here will be what? 45 degrees, and the angle here will be 45 degrees. Let's say this is A, B, and C. So let's take this triangle out. When we do that, we are going to get what? Here will be what? 90. Here will be 45 degrees. Here will be 45 degrees. Here will be the diagonal, which we don't know the length, so here will be A, and here will be A. So since this is a right angle triangle, we can what? Use Pythagoras theorem to find what? D. So from Pythagoras theorem, D squared is equal to what? A squared plus what? A squared, which will be equal to 2A squared, and that's equal to D squared. So D will be equal to square root of what? 2A. So we can redraw this to get 90 degrees. Here will be square root of 2A. Here will be A, and then this place will be A. Here is 45 degrees. Here is also 45 degrees. Yeah, that diagram is really small, but I hope you can get it. So now we are going to find the sine and cos of the angles, sine, cos, and tan of the angles that we have over here. So let's start with what? Sine 45. That's basically the only one we can find. So we know the angle here is 45, this one 45, so we can just go with 45. So sine 45 will be equal to, the opposite is what? A. So A over, the hypotenuse is square root of 2A. So you get what? 1 over square root of 2, which you can rationalize to get what? So let me just do that. And this will be equal to square root of 2 and 2. Okay. Yeah. Then let's check what cos 45. Cos 45 will be equal to the same thing, A over square root of what? 2A. Because we have the adjacent to be A and the hypotenuse to be what? 2A. and this will give us what? 1 over square root of 2, which is equal to 2 over 2. Okay, so that's why they are like this. Then we need to check for tan. I'm doing the tan at the top over here. Tan 45 degrees will be equal to hypotenuse. Opposite is what? A. Adjacent is also A. So we have what? A over A, and which is equal to 1. So that's why tan 45 is equal to 1. Okay. So basically that's it. So you're supposed to like know like you don't have to choose like memorize or be singing the song. Tan 45 is equal to 2 over 2. Those things you just have to know how to get these things. They are very simple to do. Now I want to talk to you guys about something that's really nice. If you have noticed something throughout what you have done so far, you will see there is some similarities. Okay, see we have half here by 60, and then this place is 30. What's happening? So yeah, that's what I want to talk about. So complementary angles, A plus B being equal to what? 90 degrees. We have talked about this at the beginning, okay, when we were discussing angles. So let's just go more into details, and then I think I'll end this video here and I'll continue the rest later. So if A and B add up to what? 90 degrees. In other case, if A and B are what? Complementary angles, then the theorem says that what? Sine of what? A should be equal to what? Cos of B. Okay, so we have 60 degrees and what? 30 degrees. They sum up to what? 90. 45 and 45. They sum up to what? 90. So sine of what? 60 to be equal to what? Cos of 30. And then cos of 60 should be equal to what? Sine of what? 30. And this is equal to square root of 3 over 2. And this is equal to what? Half. And then sine of 45 should be equal to what? Cos of what? 45. And this will be equal to square root of 2 over 2. So that's the whole concept here. Okay, the complementary angle. So if you are complementary angle, if A and B are complementary angles, the sine of one is equal to the cos of the other. Okay, so I'll end here and then we'll continue later.